Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. This is Ms. Rida Asif, your mathematics teacher from SM Public Academy, Campus 5. So, my dear students, what we are going to discuss today, we are going to discuss chapter number 13, the quadrilaterals. We have already discussed this chapter, but today I'm going to give you the complete explanation about quadrilaterals and its kinds. Okay, so first of all, let's discuss properly about quadrilateral. So what is a quadrilateral? By the definition, what is a quadrilateral? Here you can see the picture of quadrilateral. A figure bounded by 4 straight lines is called a quadrilateral. Okay, so here A, B, C, D, it is a quadrilateral. Now, what is called the vertices of quadrilateral? Here A, B, C, D, these are the vertices of quadrilaterals. Now, how can we define the vertices? The common points of the line segment are called the vertices of the quadrilateral. Okay, here you can see that this line AB and AD, the common point is A. So here A, B, in the same way C and D. These are called the vertices of quadrilaterals. Okay. Only if I talk about only A is the vertex of quadrilateral, and if I'm talking about all the vertices, all the vertex, so the plural of vertex is vertices. Okay. Now, sides of quadrilateral. The segments AB, BC, CA, and DA are called the sides of quadrilateral, like AB here, BC, CD, and DA. These are called the sides of quadrilaterals. Now, what are the opposite sides of quadrilateral? If I show you that in this diagram, side AB and here side CD. These are the opposite sides of quadrilateral. In the same way, side BC is opposite to side DA, right? So these are called the opposite sides of quadrilateral. Okay, so two sides of quadrilateral are called opposite if they do have a common endpoint. When they don't have any common endpoint between them, they are called opposite sides. Now the next one is adjacent or consecutive side. Now, here you can see in this diagram, side AB and side AD. These two sides are called adjacent sides. Okay, these two sides are called adjacent sides, right? Why? Because there is a common endpoint between these two sides, and the common endpoint is A. Okay, so side AD and side AB, these are called adjacent sides because there is one common endpoint between them, right? So here, two sides of quadrilaterals are called adjacents if they have a common endpoint, right? So this is all about quadrilaterals. Now, let's discuss angles of quadrilateral. Here in this diagram, let me show you A, B, C, D. So here there are 4 angles in this picture, you can see the 4 angles of quadrilateral. Angle A, right? And here angle B is there, angle C is there, and angle D is there, right? So what are called opposite angles? If two angles of quadrilateral don't have common arm, they are called opposite angle. Okay, here you can see that angle A contains the arm DAB and angle C contains the arm DCB. Okay, so arm is not common. Therefore, angle A and angle C, they are opposite angles. They are opposite angles. In the same way, according to this picture, according to this diagram, angle B and D are the opposite angles, right? Angle B and D are the opposite angles. Clear? Next, adjacent and now next is adjacent and consecutive angles. If two angles of quadrilateral have a common arm, they are called adjacent angles. For example, here angle A and angle B, they are adjacent angles. Why? Because here angle A means DAB and angle B means BAC. Angle BA, here ABC, right? So they are sharing the common arm. They are sharing the common arm. So these two angles are adjacent angles. Why? Because they have a common arm between them. So in the same way, angle B and angle C, angle B and angle C, they are adjacent angles. In the same way, angle C and angle D are adjacent angles. And in the same way, angle D and angle A, they are adjacent or consecutive angles. Clear, students? Now, what is called the diagonal? The line segment joining the opposite vertices of a quadrilateral is called a diagonal. Okay, the line segment, the joining the opposite vertices of the quadrilateral is called a diagonal. So in this diagram, here you can see this. If I join angle A and angle C with the line segment, okay, if I join the two opposite angles, okay, if I join the two opposite vertices of the quadrilateral by the line segment, this line segment is called a diagonal. In the same way, if the line segment that joins the two opposite vertices, that means B and D, it is called the diagonal of the quadrilateral. Okay, so BD and AC are the diagonals of quadrilateral. Okay. So this is all about quadrilaterals, sides and angles of quadrilaterals and diagonals. Now let's discuss kinds of quadrilateral. We are going to discuss 3 kinds of quadrilateral here. Number 1, parallelogram, like this. Number 2 is rectangle. And number 3 is a square. So let's discuss one by one. What is called a parallelogram? A quadrilateral whose both pair of opposite sides are parallel. It is called a parallelogram. A parallelogram is denoted by this symbol. Here you can see that 2 parallel lines are there and M is written over there. Okay, it is denoted by parallelogram A, B, C, D, right? ABCD, right? So here in this picture, you can see that a quadrilateral whose opposite sides are parallel. Here you can see that AB side and CD. These two sides are parallel, okay? And side BC and side AD, they are parallel to each other. So this quadrilateral is called a parallelogram, having opposite sides parallel, so symbolically we can say that side AB is parallel to side CD and side BC is parallel to side AD. Am I right? Okay. So now let's discuss the properties of parallelogram. So property number 1, opposite sides of parallelogram are congruent. Okay. The first property is also the definition that the opposite sides are parallel. So if they are parallel, they are congruent too. We can say that side AB is parallel and it is also congruent to side CD, and in the same way, side BC is equal to side AD. Okay. Number 2, opposite angle of parallelogram are congruent. Okay. Opposite angle means angle A and angle C are congruent, right? Then angle B and angle D are congruent, right? Opposite sides are congruent and opposite angles are congruent. Now, any two adjacent angles of parallelogram are supplementary. Okay. For example, angle A plus angle B. Supplementary means the sum of two angles must be equal to 180 degree. So angle A plus angle B is equals to 180 degree. In the same way, we can say that angle B plus angle C. Angle B plus angle C is equals to again 180 degree, or we can say that angle C plus angle D is equals to 180 degree. Okay, so this is the property that any two adjacent angles of parallelogram are supplementary. Supplementary means sum is equals to 180 degree. Now the diagonals. The fourth property, the last property of parallelogram is of diagonal. Okay, the diagonal of the parallelogram bisect each other. Okay, what is the meaning of bisect each other? Here you can see the diagonal number 1, AC, okay, and diagonal number 2 is BD. These two diagonal intersect each other at point O, and if these two diagonals intersect each other at point O, we can see that this measurement OA and OC, they both are equal. That means that these two diagonals are bisecting each other. Okay, they are bisecting each other. So we can say that the two diagonals bisect each other. Okay, so this is all about the properties of parallelogram. Now let's discuss the next quadrilateral. The next one is a rectangle. Now, a rectangle is a parallelogram. A rectangle is a parallelogram whose all angles are right angle. Whose all angles are right angle. Okay. Whose all angles here in this diagram, you can see the rectangle. Here, the angles A, B, C, and D, they all are equal to, all the angles are equal to 90 degree. These all angles are equal to 90 degree, right? And in rectangle, the opposite sides are congruent. That means AB, CD, they are congruent sides, and BC and AD, these two sides are congruent. So this is also the property of the parallelogram, having opposite sides congruent. So that's why it is written that the rectangle is a parallelogram. Okay, but all the angles of rectangles are of 90 degrees. So we can say that it's a parallelogram having all the angles are right angle, whose all angles are right angle. Okay, so let's discuss the properties of rectangle. So students, if a rectangle is a parallelogram, if a rectangle is a parallelogram, then the starting four properties of rectangle are similar to the properties of parallelogram. Okay, why? Because a rectangle is a parallelogram whose all angles are right angle. That means it's a parallelogram. Okay, so the properties of parallelogram are included in properties of rectangle. So the starting four properties are similar, right? So what is the starting four properties? That the opposite sides of rectangle are congruent. Yes, it is congruent. Opposite angles are congruent. That means angle A, angle C, they are congruent. Angle B, angle D, yes, they are congruent. Now property number 3, any two adjacent angles of rectangle are supplementary. Yes, obviously, if I add angle A plus angle B to 90 plus 90, we get 180 degree. It's correct. Now, the fourth property, which is also the property of parallelogram, that the diagonals of rectangle bisect each other. Okay, the diagonals of rectangle bisect each other. Right? That means here OA is equals to OC and OB is equals to OD, right? Now, the fifth property is that all the angles of rectangle are congruent. All the angles are congruent means that all the angles are equal to, here you can see that all the angles are equal to 90 degree. So here, measurement angle A, measurement angle B, C, and D, they all are equal to 90 degree. So all the angles of the rectangles are congruent. Okay. So the last property of rectangle is again of diagonals. Okay. So the last property is of diagonal. The property is the diagonal of rectangle are congruent. The diagonals of the rectangle are congruent. What is meant by congruent? Here, AC, that means the diagonal AC and BD, both are equal. Both are congruent means both are equal. If AC is equals to 10 centimeter, then BD is also is equals to 10 centimeter. Clear, everybody? So, for the rectangle's diagonal, there are two properties, that they bisect each other as well as they are congruent. But for the parallelogram, they only bisect each other. They are not congruent. They only bisect each other. Clear, everybody? So, the students, after rectangle, we are going to discuss the next quadrilateral, that is a square. So a square, what is a square? A square is a rectangle whose all sides are congruent. Okay. A square is a rectangle. Here in this diagram, you can see that all the sides are now congruent. Okay. But the angles are all equal to right angle. That means are of 90 degree. So it is a rectangle having all the sides are congruent. So if the square is a rectangle, that means all the properties of the rectangles are also included in square. So here the properties of square, here you can see that there are 8 properties of square, in which starting 6 properties are there, which we have already discussed in rectangle. That number 1, opposite sides are congruent. Yes, opposite side AB and CD are congruent. Opposite angles are congruent. So A and angle C are congruent. Now any two adjacent angles of square are supplementary. Yes, A plus B is equals to 180 degree, because all the angles again are of 90 degree. So the diagonals of the square bisect each other. That means OA and OC are equal. Next one, all the angles are congruent. That means angle A, angle B, C, and angle D are is equals to 90 degree. Right? Now, 7th and 8th property. 7th property is all the sides are congruent. That means AB is equals to BC is equals to CD is equals to DA. Okay. These all sides are congruent. These all sides are congruent. Now the last property of square is of diagonals. Okay. Diagonals. The diagonal of the square are perpendicular to each other. Perpendicular means here AC and BD, when they intersect each other, they are perpendicular. Perpendicular means that here the angles are of 90 degree. Here these angles are of 90 degree. Okay. Their diagonals are perpendicular to each other. So what are the 3 properties for the diagonals of the square? That they bisect each other, as well as they are congruent and they are perpendicular to each other. So if I ask you that the diagonals of rectangle are perpendicular to each other, so what will you say? Yes, it's false. Okay. And if I ask you the diagonals of parallelogram bisect each other, yes, it's true. The diagonals of square perpendicular to each other, yes, it's true. So properly you have to learn these properties properly. Okay. The properties of these quadrilaterals are given in your book on page number 166, 167, and 168. Okay. So learn these properties properly, learn the definitions properly. Construction of quadrilaterals. So there are 3 kinds of quadrilateral in this chapter. We have discussed parallelogram, rectangles, and square. And there are two cases of each. Okay. So today we are going to discuss the construction of a square. When the measure of its sides are given, and case number 2 is when measure of the diagonal is given. Okay. So the case number 1 is when measure of its side are given. Now construct a square whose side is 5 centimeter. Write briefly its steps of construction. This is all about. Okay. Now, only one side is given. Okay, in this question only one side is given. So how can we draw the square? How can we construct the square? Obviously, if one side is given, so according to the definition, we know that all the sides are congruent in square. So if one side is equals to 5 centimeter, all the other sides are also equals to 5 centimeters. So first we have to write given that in a square. Acha, one more thing that in this question, nothing is mentioned that which square name is not mentioned. Vertices are not mentioned. So you can mention the name. It's up to you. You can mention the name ABCD. You can mention the name PQRS. Okay. Here I have taken the name ABCD. Okay, so in the square ABCD, measurement AB is equals to 5 centimeter. Okay, it is given. What we have to do, we have to construct a square ABCD. Okay, now let's start constructing a square, right? Let's start constructing a square together. Step number 1, we have to draw a line segment of 5 centimeter. Let's mention the name AB. Okay, we have drawn a line segment. AB is equals to 5 centimeter. So step number 1 is draw AB is equals to 5 centimeter. Now the next step is we have to draw a perpendicular here on B. Okay, as we know that all the angles of a square are equal to 90 degree. So here we are going to draw a perpendicular on B like this. First we have to put the compass on B. We have to open the compass here half or more than half, and we have to draw the semicircle. Then we have to put the compass here on this intersecting point. We have to make two arcs, and then we have to make we have to make two more arcs, and then we have to draw a ray. Okay, why we have to draw the ray, students? Because we don't know the ending point. Okay, uh, it can extend indefinitely only in one direction, so we have to make a arrowhead over there. Okay, and I have mentioned the name X. So I have drawn a perpendicular on AB. Okay, I have drawn BX, which is perpendicular to AB. So step number 2 is at B, draw BX perpendicular to AB. Perpendicular to AB. Okay. Now, what we can do here, we can put the compass on B. Okay, we have to put the compass on B, and with the measurement of 5 centimeter, we have to draw an arc over here on BX. We have to draw an arc. Okay, so we have to put the compass on B, and we have to draw an arc here of 5 centimeter. And this arc can be mentioned as here the point where this arc intersect this BX. This point is only called C. Which point is called C? Not the whole arc. Not the whole arc, only the point here. This point is called C. Where this arc intersects this ray BX, this point is called C. Is it clear? So what will be the next step of construction? The next step will be from BX, cut off BC is equals to 5 centimeter. Or you can say that be a center with radius 5 centimeter, draw an arc which cut BX at point C. Clear? Now you have to put the compass at C with the measurement of again 5 centimeter. you have to draw an arc like this. Okay, you have to put the compass at C with the measurement of again 5 centimeter, because it's a square having four sides equal. So draw an arc. So see a center with radius 5 centimeter, draw an arc. Now the next step is we have to put the compass at A. Okay, now we have to put the compass at A with the measurement of 5 centimeter again. We have to draw another arc like this, which intersect the previous arc at point D. Okay, which intersect the previous arc at point D. Okay, then what we have to do, we have to join C to D properly. Okay, now students, make it very clear that we have to draw the line properly here like this. Okay, avoid drawing the line like this that joins C and D like this. But this is not D. This point is not D. Okay, this is not D. Where is D? Where these two arc intersect. Only this point is called D. Okay, where the two arc intersect, this point is called D. This point is called D. So properly join C to D like this. Take the scale in your hand and join C to D properly. Okay, join C to D and D to A. Okay, so here we have written that A center with radius 5 centimeter. Draw an arc intersecting the first arc at D. Now finally, when we get D, then join A to D and C to D. Okay, so ABCD is our required square. Clear, students? Here you can also mention 5 centimeter, and here you can mention here also that this is of 5 centimeter. Clear? Is it clear? Everything is clear with it? What we have done, first we have to draw the line segment AB, then we have to draw the perpendicular. Okay, after drawing the perpendicular, we have to put the compass at B and draw an arc. We get C. Then we have to put the compass here on C and we have to draw an arc here. And then we have to put the compass at A and we have to draw another arc to get D. Okay, and then just join C to D and A to D. Clear, everybody? Now the next one is construct a square when it's diagonal. This is a case number 2 when the diagonal is given. Measurement AC is equals to 6. Measurement AC is equal to 6 centimeter. Write briefly its steps of construction. Now what is given in this question? In a square ABCD, diagonal measurement AC is given, that is equal to 6 centimeter. What we have to do, what is required, we have to construct the square ABCD. Now, before making a proper square, we have to, what we have to do, students, we have to construct a rough sketch over there. And if we draw a rough sketch of ABCD here, this is A. Okay, here we have to mention B, then this is C, and this is D, right? This is D. So what is given in this question, Vijay? What is given? Diagonal AC is given. Diagonal AC is given. This is of 6 centimeter. So how can we construct a square when the sides are not given to you? Okay, please remember this point that here diagonal is given. Don't draw the diagram like this, that write down 6 centimeter and write down AB over here. Please remember this point, that if the diagonal is of 6 centimeter, sides cannot be equal to 6 centimeter. Okay, because in square the sides are congruent, all the sides are congruent. We are not talking about the diagonals. Okay, so avoid making the making the square like this. Don't write B over here, you have to write C. Okay, because the diagonal is given of 6 centimeter. So what will be the step number 1? We have to construct, we have to draw the line segment that is diagonal AC is equals to 6 centimeter. We have to draw the diagonal AC. Okay, we have to draw the diagonal AC is equals to 6 centimeter properly. Let's start making the square. So step number 1 is draw the line segment AC is equals to 6 centimeter, right? And write down the step that draw AC is equals to 6 centimeter. Now step number 2, what we have to do, students, we have to put the compass here at C. Okay, we have to put the compass at C. We have to open the compass more than half, and we have to draw two arcs, one above and one below the line segment. Okay, one above and one below this line segment. In the same way, we have to put the compass at A with the same opening of the compass. We have to make the two more arcs, one above, one below this line segment. These two arcs must intersect the two previous arcs which we have drawn by putting the compass at C. Okay, now what we can do here, we have to take scale, a ruler in our hand, and we have to draw the bisector EF over there, which intersect AC at point O. Okay, we have to draw the bisector EF which intersect AC at point O. What we have done, student, here we just have drawn a right bisector which bisect AC in two equal parts. Okay, if you will check the measurement of OA or OC, it must be equal to 3 centimeter. Okay, because we have drawn the right bisector which has bisected this AC in two equal parts, in two congruent parts. Okay, this is the property of diagonal of square, that the bisector must be the diagonal must be here OA and OC, it must be equal, it must be congruent. So here we have drawn the right bisector which bisect the diagonal AC into equal parts. So let's write down the steps together. Draw EF, the right bisector of AC intersecting it at O. Okay, here we have drawn the bisector EF, and the students, you can see that there are two arrows. You can see the two arrowheads on E and F, which shows that it's a straight line. Okay, straight lines that it can extend indefinitely in both the direction. There's no ending point of E and F. So we have drawn the right bisector with the two arrowheads, and in the same way we have written here in the steps of construction, we have mentioned the straight line over there with the two arrowheads. Okay, so we have drawn a right bisector AC. right bisector of AC intersecting it at point O. Now what we have to do, students, we have to put the compass. What we have to do, we have to put the compass here on this point O, and we have to open the compass till point C, or we can say that we have to put the compass O and we have to open the compass at till point A with the measurement of OA or with the measurement of OC. We have to draw two arcs, one above and one below the line segment AC. These two arcs must intersect E and F straight line at point B and at point D. What we have done, I'm again telling you, we have to put the compass here on this point called O, and with the measurement of OC. With this measurement, we have to open the compass from O till C or O till A, and then what we have to do, we have to draw two arcs. We have to draw two arcs here on above the line segment AC on EF and below the line segment AC on EF to get B and D. Now the two arcs, where the two arcs intersect EF, this intersecting point is called B, and where this arc intersect EF, this point is called D. Okay, this intersecting point is called D, right? Now what we have to do, the last step is, okay, now steps of construction, you can see that O is center with radius OA and OC. Draw arcs. What we have done, draw arcs which intersect E and F at point B and D. Okay, at point B and D. Now finally, what we have to do, students, take the scale in your hand, take the ruler in your hand, and then join this point A, B, join B to C, and join C to D, and join D to A properly. Okay, join A to B, B to C, C to D, and D to A respectively. Here you get finally the last step of construction. Join A to B, B to C, C to D, and D to A. So square ABCD is our required square. Now students, when you measure this BD, when you measure this BD, this must be equal to 6 centimeter. And if BD is equals to 6 centimeter, that means your construction of square is correct. Okay. Why BD must be equal to 6 centimeter? Because AC and BD, these are the diagonals. And the diagonals of the square bisect each other. They are congruent and they are perpendicular as well. So if BD and AC both are equal to each other, that means you have drawn the correct square. Now, one more thing. How can you check your square? How can you check the measurement of the sides of your square? Just take the scale ruler in your hand and put it at AB. Just check out the measurement AB. If AB and measurement BC and measurement CD and measurement DA, all the measurements are equal. For example, if measurement AB is equals to 4.8 centimeter and all the measurements are of 4.8 centimeter, that means you have drawn the perfect and proper square. Okay, is it clear? Is it clear, students? So in this way, we can draw the square when measures of a diagonal is given, and the case number 1 is when measure of its sides are given. Is it clear? I hope that today's lecture is properly clear to you. Thank you so much, my dear ones. Take care of yourself and Allah Hafiz.